One right off the bat, parallel lines. Can you guys do me a favor and draw your cube from yesterday, please, for the diagram for this? All right, draw a cube for me. I think we have all heard from Algebra 1 days of parallel lines on a graph. I just want to make sure if we throw them on some planes, you guys know what the deal is. And you can see over there, boss? You all right over there?
Can you move over that?
For you? Sure. You gonna put in the effort, I expect, because I'll do it then? All right, good deal. Better?
Yeah, that's good.
How about you guys over here, all right, in this first row if I do that? All right, just want to make sure we're in the best spot possible. All right, parallel lines. Yesterday we described, how many planes did I just draw there with the cube? How many planes? 6 planes, right? Here, parallel lines have to be on the same plane. So you're about to give me 2 lines that are on one of those 6 planes, but do not intersect. That's what I'm going to ask somebody for right now. Give me 2 lines that are on one of those 6 planes, but do not intersect either, and you gave me a set of parallel lines. What do you think are parallel up here? 2, 0. Here we go. Addie? AD and DE?
No, GE.
AD and, yep, fine. Those are fine. So everyone ready? AD. Make sure we use our symbols. Let's start using them. And anybody know, I'm going to introduce this for the first time right now. Anybody know the symbol for parallel? The mathematical symbol, because I'm not going to have you spell it out. Lisa?
Like 2 lines.
Darn right. 2 vertical lines. Nice job. AD parallel to GE. I'm hungry, though. I'm hungry. I want another pair. Let's go. Feed it. Feed the beast. 22. Aiden, what do you got over there?
FE and CG.
FE and
CG.
CG?
Or GH.
GH, that's fine. Yep. So line EF parallel to line GH. Good work, everyone. Good work. So they have to be on the same plane and they cannot intersect. All right, your turn now. Your turn. I got my diagram, my triangular prism here. Can you only do one? It says name all, but only do one. Can you name a line that's parallel to AC, a line that's parallel to EF, and a line that's parallel to AD? Go ahead. Give you about a minute. Use your line symbols, please. Remember, they have to be on the same plane, but do not intersect. So find something that's on the same plane with AC, but does not intersect it. So AC and what else are parallel? EF and what else are parallel? Oh, what do you say? What do you say? AC and
DF.
Relax, George. Can I call on you first? All right, relax, boss. What do you have? AC and what?
DF.
DF. Thank you. Yep. Just trying to show off. I get it. EF and 20. Oh, Addie, back to you. EF and one more time. BC. A little school spirit there. Yep, good. And then how about something that's parallel to AD for me? AD 21. Ooh. How about Molly?
CF.
AD and CF. I got you. Yep, thank you. All right, so it seems like we're pretty good at identifying 2 parallel lines. All right, now it's a little bit different. Skew lines. Lines that are skew. This is a little bit tougher concept to pick up. First, let's just read over that definition because that sounds crazy. There are 2 lines not on the same plane, so they can't be on the same plane, unlike parallel lines. All right, so 2 lines, can't have them on the same plane. Then look at this. They're not parallel, and they can't intersect. How is that humanly possible? If they're not parallel, shouldn't they intersect? Right? You guys learned that a couple years ago? So they can't be on the same plane, they can't be parallel, and they can't intersect. How is that going to happen? Ready? Here's my, look, you want to hold that bad boy up for me?
Sure.
It's right there. Your shoulder's going to hurt, you're going to be all right. You got that? Yeah. Okay, thanks for toughing it out. I'm going to borrow your pencil too. All right, here's what skew lines mean. You got to think of it as three-dimensional right now. Everyone ready? Everyone see, thank you. Everyone see my line right here? All good? Everyone see my line right here? Are those on the same plane? No. One's on the left here, this is on the top. Are they parallel?
No.
Now here's the big thing. Think of it in three-dimensional space. Are these ever going to intersect these lines? No, right? One's on top, one's on the bottom going this way. They'll never intersect. These are skew lines. Take a look again. These are skew lines. Not on the same plane. Definitely not parallel and will not intersect in three-dimensional space. All good? Should I just keep talking so he's got to hold it up? Everyone good? Skew lines. Understand the meaning by this visual? Perfect. Thanks, bud. Appreciate it. All right, so let's go back to my diagram. AC. Can you find anything that would be skew to AC now? Not on the same plane, so don't pick AB or BC. Nothing parallel to it, so don't pick DF. But can you find a line that won't intersect it? Anybody think they have it? Whoa, jeez. Callum, go ahead.
DE.
DE is a good one, yep. And by the way, if you didn't have DE, that's fine. There's multiple lines that are skew to AC. Some, obviously not AB, BC, or DF. All right, anybody got anything that's skew to EF? Skew to EF. Jeez, it's going to be a while. Sorry, everybody, before I start doing this. Emma, go ahead.
DA.
DA, yep. Jeez. And how about skew to AD? You can, if you want to cheat, you can, but hopefully not, right? What you got, Zach?
EF.
Oh, you son of a gun. Couldn't be more original. Had to just piggyback from number 5. It's all right. I see what you're doing. You probably don't even know that you did that anyway. Skew lines, we all good? I don't want to take too much more time. Not on the same plane. Definitely not parallel. Can't intersect in three-dimensional space. All right, here we go. Oh, flip. Nice. Lines can be parallel. So can planes. Planes can be parallel. 2 planes that don't intersect. They don't touch each other. Look at my diagram. I hate to break it to you. There's only one pair of parallel planes on there. Can you find it? There's only 2 planes on my diagram that will not intersect here. All right, they are parallel. All right, make sure you name it with 3 letters, remember? Via, go.
Is it triangle?
Oh, triangle. Relax. Plane.
Plane.
Yeah.
Plane. Oh, sorry. Plane A, B, C, and plane D, E, F.
Yep. Plane ABC and plane DEF. Good. Those are the only 2. Those are the only 2. Everything else intersects each other. Okay, now, can a line and a plane be parallel? We know 2 lines can be parallel, 2 planes can be parallel. Can one of each be parallel to each other? And the answer is yes. Here's how. I want to make sure I say this correctly and slowly. If 2 planes are parallel, do we have 2 planes parallel, by the way, in this diagram? Yeah, Via just gave it to us. If 2 planes are parallel, any line from one plane is parallel to the other plane. Let me say that again. Any line on one plane is parallel to the other plane. So somebody give me a line on plane ABC. Go ahead, spat it out. Give me a line on plane ABC. AC? All right, I heard AC first. So line AC line AC is parallel to the entire plane DEF. See what I mean? If two planes are parallel, any line on one plane is parallel to the other plane. Make sense? All good? I don't want to spend too much time on that. All right, I'm sure you're happy we're done with planes. Finally, we're done with planes. Now we're going to go into some different territory. Anybody remember yesterday when I made a huge deal when I introduced a line and I said, you got to have arrows on it, right? Because I said, if you don't have arrows on it, it's something new. That's what this is, a line segment. It's a line without the arrows. Okay, that's what a line segment is. Take a line, take off the arrows, you got a line segment. So let's draw our first line segment together. It has endpoints. Endpoints. All right, there's a line segment. It ends. Does not go on forever like a line. And we'll just call this A, B. How do I write that mathematically? You guys remember yesterday we had the line symbol to write it? You got a line segment symbol. Same thing. Boom. And guess what goes underneath it? The endpoints. Whatever the endpoints are, order does not matter. A, B, B, A in this case. Okay? That's how you write a line segment. If it's a line, you put the arrows on it. If it's a line segment, you take them off. Real quickly, don't write this on your notes, please. Let's say I just throw point C in there. You still have to call this line segment AB. You can't call it AC because then everyone see that's a different line segment. That's this bad boy right here. Okay, so you have to put the endpoints underneath the symbol. Any issues? All right, some of you guys are going to start shaking now and sweating, maybe crying. There's tissues on my desk back there if you need them. We're going to do some algebra now. All right, we're going to mix some geometry and algebra together. All right, here we go. What's it asking me to do? Draw. What's this saying? Talk to me. Talk geometry to me. Draw what? Line segment EG. Go ahead. Draw a line segment EG. Don't worry about length. If it's going vertically, horizontally, diagonally, who cares? E, G. F is somewhere on that segment. Does it tell me where? So who cares? Go ahead. Point F is somewhere on that segment. Doesn't tell me where, so just put it anywhere. All right, next up. If EG is 100. Now look, does everyone see I took the symbol off? I don't have the line segment symbol. Do we see that? If you don't see the symbol, it's telling you how long it is. All right? No symbol means, oh, EG is 100 units long. And however you want to write that on your diagram. All right? So if I take the symbol off, it's telling me how long it is. How long is EF? 4x minus 20. So EF, 4x minus 20. That's the length of EF. And FG has a length of 2x plus 30. It's a three-part question. Find x, find the length of EF, and find the length of FG. Is F directly in the middle? No, it just said it was on there. So do not think 4x minus 20 equals 2x plus 30. That's incorrect. It didn't tell me where F was. All right, I need your help. Can you set me up something so I can solve this first part for x? Is there something, an equation, you can set up for me so I can solve this for x? And we already said those two are not equal to each other because F's not in the middle. Need a little help. Lisa, got us?
4x minus 20 plus 2x plus 30 equals 100.
Good. 4x minus 20, the one part, plus the other part, 2x plus 30, equals the whole segment, 100. Everyone's all right? Are we okay on where that came from? Because that's basic. You're going to see a lot more advanced stuff in this class than this. All good? Add up the two parts, it gives me the whole. All right. I can't help you solve it. All right. You got to come into this class with that ability. All right. I can't help you solve this for x. That's your algebra talking. So combine your like terms. You get 6x plus 10. Hopefully I'm not blowing minds here. I know we'd had a summer off, but this is even last year's stuff. We got to go back to the middle school to do this. Then what? Go ahead now. Go ahead.
Subtract 10 from 100.
Get the 10 on the other side by subtracting it. 6x equals a 90 spot. Now what? Divide by 6. X equals 15. And I'm going through that quick. Just if you're in here, I feel like you should know that. I can only give you 1/3 of credit, though. Unfortunately, you're not going to get full credit. If this was 3 points, I'd only give you 1. So why do you?
It's because you didn't really solve like the the length is of E, F, and FG.
How about you read the darn problem, right? It said solve x, then we got to keep going. All right, how do I find the length of EF now that I know x? Suggestions? How do I find the length of EF? We got in.
You substitute x in for 15.
Yep, plug and chug. I like to say that, plug and chug. So 4, now you plug that sucker in, 15 minus 20. And that'll give you the length of EF. I got you, 60 minus 20, 40. So EF is 40. And then keep going, keep going. I'm asking for the length of FG. Now, you don't have to plug it in. You can know that the whole thing's 100, other part's 60. A couple different ways you could find it without, you don't have to. You could plug it in, but you don't have to. And then FG is going to be 60 units long. Perfect. A little algebra for you. A little algebra. Any questions? Not bad? Okay, we can add like we did here, and we can also subtract. Flip. All right, go ahead, draw. You guys can read it now. Draw. What's it asking me to draw? Talk to me in some geometry terms. Draw. Line segment RS. So your endpoint should be R and S. I just want you guys to talk to me using this new vocabulary. P is a point on the segment. Does it say where? Nope. So you can put it anywhere you'd like. This is a quick one. All right, this should be a real quick one. What's this telling me here? RS equals 24. What's it telling me? The length is 24, right? So RS is 24 units long. RP is 10 units long. Find the length of PS. All right, I'm nothing crazy here. Nothing crazy. We can add segments together like we did in the last one, and here we can also subtract segments. So I got to call on more people here. How do you find the length of PS? No 5, huh? There we go. Karen, how do you find RS? PS, sorry.
24 minus 10.
Ooh, you okay? You all right after that one?
Yeah.
What do we get?
14.
There you go. Whew. Just wanted to show you can subtract them too. Okay, you feel pretty good? Because I got one more term, and this term is huge, huge term. Because we're going to be talking about it day in and day out, and that's congruent. What congruent segments are. Basically, if two segments are congruent, they have the same length. If two segments are congruent, they have the same length. So what I'd like you to do right now is draw 2 line segments for me that look like they're about the same length. Go ahead. 2 line segments, call them A, B, and CD, that look like they're the same length. Okay, call one segment AB, the other CD. how are you going to know that they're the same length? The only way you would probably know, and don't write this on your diagram, do not write this on your diagram. The only way you're probably going to know is if I tell you the lengths, right? Let's say that's 3 inches and that's 3 inches. That's the only way you guys are going to know that they're the same length, right? I'm never going to do that though. You're never going to see this on a book, test, or quiz, the actual length. So how in the world are you going to know if they're the same length or not? What you're going to see starting now is you're going to see the diagram marked with what's called hash marks. Now you can put this on your diagram. You're going to see a hash mark here and one hash mark on the other segment. That is telling you they are congruent. If I see those hash marks, I don't need to know how long they are. I know they're the same length. Everyone good? I know they're the same length, which makes them what? What's the vocabulary term if they're the same length? Congruent. How do I write now that they're congruent? That's the final thing I need to show you. How do I write mathematically that AB and CD are congruent? Well, you know how to write AB, right? Line segment AB. Go ahead. Line segment AB. Anybody know this math symbol for congruent? It's a rare one to know. It's the equal sign with the little, what's called a tilde above it. You can call it a squiggly, but I'm not going to take that for much longer. That is the symbol for congruent. And then that is congruent to line segment CD. That's how I would write that. A, B, and CD are congruent. They have the hash marks on it. That tells me they're the same length. All right? All right, we got one more question for you before we call it a day, and you can start the homework. Using my diagram and my markings, can you figure out which one of these 4 choices is incorrect? Incorrect. You guys see the hash marks? Right away, right away, just by looking at the diagram. What do you know about A, B, and CD? Congruent. They're already congruent based on the diagram and the hash marks. So I will let you go through each of these 4 choices and see what you think. I won't call on anybody, but see what you think. You already know A, B, and CD are congruent. I gave you that because of the hash marks. So knowing that, which statement is incorrect? Incorrect. All right, let's go choice by choice. Number 1, AB congruent to CD. Is that correct? Darn right, I gave you the hash marks. Now I take it off. What's number 2 say? Is AB the same length as CD? Yes? Yeah, why? Because we were told at the beginning they're what? Congruent. That's the definition of congruent. They're the same length. So 2 is fine. How about 3? Now we get a little crazy. Is AC the same length as BD? Yeah, it is. Here's why. I think it may be helpful if I put numbers on here. Watch. Let's say AB is a length of 2. What's the length of CD? 2, because they're congruent. Let's say BC. How long you want BC to be? 5? Sure. All right, ready? How long's AC now? 7. How long's BD? 7. Why? Because I'm adding the same thing, BC, to 2 congruent parts. So the result should be equal. What's the incorrect one? AC is not the same length as CD. Okay, that is incorrect. All right. Warning, homework is partially in your packet on page 9. The rest of the homework is in your book. So you guys can get rolling. Go ahead. I'll be here to answer any questions. So some of it's on page 9, some of it's in the book, but all the answers are on Classroom.